Okay, so the purpose of this talk, my name is Mario. The purpose of this talk is to explain a little bit, if you're familiar with WPE, the WebKit port for embedded devices, to give some ideas on, based on our experience, what is a good way to build a successful embedded product in that it doesn't give you too much trouble for integration and it allows you to leverage the potential of the web engine in the best possible way. Hopefully this will be helpful. So first, a quick introduction about myself. I am Mario. I'm a software engineer. I work at Igalia. I've been working at Igalia for 14 years now. I've been involved in open source for a long time. I've been working, I think, for 18 years in open source, mainly in many different projects, but mainly in the GNOME, the WebKit and Chromium community. I did also other work in the past, based mainly around Linux-based operating systems, like Endless OS, Little OS, or if you remember the Nokia times, Maemo. I worked for a while as well in the Samsung Smart TV platform, and these days I don't do that much development. I spend most of my time coordinating the Igalia team we have the WebKit team we have at Igalia. About Igalia, if you're not familiar with us, we are an open source consultancy. We were founded 24 years ago in the northwest of Spain. We operate an unusual flat structure. We like to say that we are a worker-owned cooperative. And we are fully remote these days. We are 160-something people in 20-something countries, 25, 26. The important point for the point of this presentation is that we are also top contributors to the main web engines, including WebKit, of course, Chromium, Gecko, and also Servo. We also contribute to many other projects, from compilers, graphics, multimedia, the Linux kernel, and as a consequence of all this, we are also members of different working groups. So the outline of this presentation, my idea is to get an introduction on web engines, WPE, to get to answer the question on why we think web engines matter in embedded devices, and then based on our experience to share some common pitfalls we have observed, possible benefits of integrating more closely with upstream, some best practices to avoid those pitfalls and have a nice experience with WPE. And if we have time, a couple of real-world case studies based on, again, on our customers, on our experience. So why do web engines matter in embedded devices? So the first question to answer is, what is a web engine? I don't know, are you familiar with the concept of web engine? More or less, okay. Let's go quickly through that. So I guess the easiest way to describe a web engine is like this is the software component that allows you to use the web platform. If you think of a browser, the web engine is the internal component every browser uses to provide you that functionality. So we basically take a browser, remove the back and forward buttons, remove the UI, just leave the thing in the middle that shows you the website and allows you to interact with that. And that is the job of the web engine. In the case of Safari, that web engine is WebKit. In the case of Google Chrome, that web engine is actually called Chromium/Blink. In the case of Firefox, that web engine is called Gecko. So the mission of this web component is to basically retrieve all the information from the internet, all the documents, parse those documents, interpret them, and produce a result you can interact with. And as you can imagine, it's an extremely flexible platform. So what is WebKit? Like I anticipated, it's a web engine. It's the web engine that is behind Safari and both in Mac and in iOS. It's also used in many embedded devices, but I will get to that. It's open source. It's released under permissive license, mainly BSD and LGPL version 2. It was initiated by Apple in 2001 as a fork of HTML. And its main features are the ones that you will expect from any web engine. And actually, the first three ones are common to Chromium and Gecko. Like on that is a complete implementation of the web platform. You can browse any website. Its performance is stable, and privacy and security are top priorities. What sets WebKit apart compared to Chromium and Gecko is that also is a top priority of it is to be embeddable, which means that WebKit guarantees you a clean public API that is going to remain stable, so that you can build your applications on top of it. This is completely different from Chromium and Gecko. It also supports different platforms, both in desktop and mobile, like Mac OS, Windows, Linux, and more recently, we are working in adding support for Android. And it's present in many embedded devices through WPE, which is something I'm going to get into a bit later. In order to support platforms, there is this concept of a WebKit port. So the summary of what a WebKit port is basically adaptation of WebKit to a specific platform. Basically, take all the general WebKit code that all the ports use, and then add whatever platform-specific low-level plumbing you need for things like networking or graphics or multimedia, and you get a port. The official WebKit ports these days, and integrated in the Stream repository, are the ones for Mac, iOS, Windows, also PlayStation. And then in Linux, we have 2 ports, WebKit GTK, which is oriented to desktop-like environments, basically GTK applications, and WPE, which is more oriented to embedded devices. They share a lot of a lot of code, but there are key differences in how they use the graphics stack, how they process input, and also the use cases. In particular, WPE, its goal is to be optimized for embedded devices, the devices like a Raspberry Pi, an IMX board, a Broadcom device, a Rock chip device, all those kind of things. So in order to support embedded devices, we did a big effort in focusing on flexibility. So this is as flexible as a web engine can get. Of course, it's also performance and security, but flexibility is a big thing. And in order to achieve this, we have an architecture that is based in backends for input and output. This means that you can basically integrate with any kind of input or output you can think of. Also, because embedded is the target, we have a minimal set of dependencies so that you don't have to pull the entire world, and a low resource footprint. Also, if hardware acceleration is an option in your device, we also try to support it as much as possible so that you can release the CPU and use the GPU as much as possible. And last but not least, and this is very important, is actively maintained upstream. So like I said, WebKit is the base of Safari, so all the changes, all the new improvements that WebKit is getting, not just in the Linux port, but also on other ports, WPE is benefiting of it. But it's important to stress the fact that it doesn't require a toolkit. It doesn't come with any UI toolkit. You can provide integration with input and output through backends. If you don't want to provide your own backends and the default ones for Wayland, for DRM, or even for headless are okay for you, you can take the default ones, that's fine. But it doesn't force you to do that. And this is nice because it opens the door to very interesting use cases that are not the common ones. Some examples of WPE-based projects you have, well, easiest to think of, devices with screens, like a fridge or a TV or a GPS device. Basically, the interface is developed with web technologies, and WPE is the component that makes sure that you can see the result and interact with it. But then also less common cases like headless server-side rendering, or even for QA and testing. Microsoft Playwright, for instance, uses WPE for headless testing, or even sound systems. So now, coming to the original question of this section, why is this important for embedded devices? So first of all, a web engine is a very complex piece of software. You can think of it as almost as, or I like to think of it as an operating system on top of another operating system, because it has to deal with many things like rendering, networking, security, accessibility, many things that you will consider from an operating system. This is very complex, but this complexity gets it a strategic role in the whole software stack. And with this strategic role, you can think of building all sorts of applications. And this gives you a terrific flexibility to design, implement, or test your applications. The other nice thing is that in order to develop those applications, you are using web technologies. This means that you can use the huge pool of web developers that are already out there to implement or to design your products. And like I said, all kinds of products you can design. However, using a web engine effectively, you can use it, like, just take it and use it. But if you want to use it effectively for the long term, it's important to remove this thinking of, okay, I'm just going to take it and I will fix things when they break. So some common pitfalls we observe while working on WPE. I have to mention that WPE is now about 11 years old, so we have quite some experience here. And when working with customers, we observe that there are some pitfalls. Probably this is not an exhaustive list, but what all these things have in common is that if you fall into these traps, you easily will end up creating a lot of technical debt. And this will make your life harder. Integration will be harder, you will be less efficient, and as a consequence of this, your maintenance cost will increase a lot. So the first one is treating WPE as a black box. This means that you just take the package from I don't know, a distribution, or you take the tarball and you use it as is. It seems it's working, so it might be good. This could be okay, but there are several risks here. First, you might be missing opportunities for improvements of optimizations. Maybe it's working, but are you sure you're using the right compilation flags, the right compilation options, the right configuration? The second risk is that you might encounter fixes, and it's tempting to just work them around or fix them in your own way without integrating with or discussing with the community. And that's fine, but you might find yourself fixing issues that are already being solved upstream, or that if you're doing this and other companies doing exactly the same thing, you might be fixing, and another company might be fixing exactly the same issue. So it could duplicate efforts. There is no magic trick for this. The possible solutions we recommend is that you allocate time. Time for understanding the software stack, which is complex, and time for contributing back upstream whenever possible. If you manage to do this, which I understand is not always easy or possible, but you manage to do this, you will find that WPE will become a strategic advantage for you, because you will be able to adapt it and use it to your advantage, instead of a liability that you don't understand, and every time that something goes wrong, it's hard to fix. The second point is actually 2 points, but they are related. It's basically when you do rebases not very frequently, and you also combine that with doing a lot of patches downstream. In this case, the net effect is that you start accumulating a lot of patches, and then the delta becomes too big, and then whenever you have to integrate a new release, integration becomes very problematic. You get merge conflicts, you get bugs that you don't know where they are coming from. All this is very time-consuming, and you end up spending your time fixing things, putting out fires, instead of working on strategic development for features. Possible solutions, like stating the obvious: try to rebase more often. If you find something that you can contribute back upstream, try to do it. And if you, many times you cannot just contribute a patch upstream right away. Maybe you want to prototype it downstream, and you keep it downstream for a while. But if you do it with the mindset of, I will do this for now, I will test it, and in parallel, I will contribute it upstream. Once that patch lands upstream and you get the new release that includes that patch, you will be able to drop it, which is a good downstream practice. This is important because if you follow this advice and you avoid this, you will find that your integration process will become much easier. And on top of that, you will prevent security problems that, because you're rebasing more often, you're also getting fixes for security issues more often. The other pitfall is when you delay feedback with upstream. Let's say that you find an issue, you fix it your own way, but you don't communicate that to upstream. And let's say other companies do the same thing, so upstream is not aware of this. And first, you reduce your ability to get support from the community, because maybe you fix the issue, but are you sure you fix it in the best possible way? You might not be a domain expert on that particular thing. But if you discuss this with the community, you might get valuable feedback from the people who actually understand that better. Again, the other risk is that if you are not doing this right, you might end up doing a lot of duplicated work. So possible solutions for this, we recommend that you engage in discussions with the community as much as possible in public channels, and also that when you find an issue, please try to report it immediately, ideally with a reduced test case. So let's try to avoid to send things like, okay, in this huge page that has a lot of code, this breaks in this way. If you can do the work of reducing the test case to something minimal, that makes everyone's life much easier. And this is important because if you do this, you are going to be, first, improving your relationship with upstream. That, believe me, is going to pay off. And second, it will reduce the chances for duplicated efforts. And the last pitfall is when your goals are not aligned with upstream. Okay, so I understand perfectly that not always, if everyone's goals were the same, yeah, this will be kind of an ideal world. This is not realistic, but the more aligned you are with the upstream roadmap, the easier it will be for you to follow your goals with minimal maintenance work. If you don't do this, if you diverge too much, you might end up having like a massive fork that is going to be very costly to maintain. Every time your rebase is going to be hell. And on top of that, your fork will probably start requiring patches that are not going to be upstreamable. So basically, it's like the problem, the snowball is growing and growing and growing. So possible solutions, we do encourage people to engage in roadmap discussions upstream as much as possible. We recommend people to contribute back to the upstream project as much as possible. And if there's something that you need upstream that is not there yet, either strategically thinking of working on on that feature that you need upstream, or if you don't know how to do it or you cannot do it, get external help and try to fund the work. And this is important because if you do this, you will maximize your efficiency doing the integration work. And on top of that, because you are going to be aligned, you know where upstream is going, where you want to be going, you will also have a clearer idea of whether you are going to diverge too much in the future or not, so this keeps you more on a realistic path for future upgrades. So everything is going in the direction of getting closer to upstream. And by the way, many of these advices, I guess, could apply to many open source projects. I'm just applying them here to WPE because it's a particularly complex, a web engine is a particularly complex project, and the risks of things going badly, I guess, are higher than in other projects. So what are the benefits that we see of a tighter relationship with upstream? So there are different aspects. Regarding to stability and security, we think that a close relationship with upstream will allow you to receive fixes as soon as possible, sometimes even also fixes to CVEs, to security issues, even before full public disclosure. This will minimize your exposure to those issues and also will eliminate the costly, urgent patches and workarounds that sometimes you have to do. And as a result, you will have a more stable product because you will basically be testing fixes earlier and you will reduce regressions when deploying to production. Related performance, you have to consider that upstream is continuously applying and landing optimizations and performance improvements. So if you align better with upstream, you will benefit immediately from these changes. These are already verified by upstream, by the way, and the other advantage is that it can help you, steer the development work upstream in the direction that is most interesting for you and your products. On top of that, you will get a more clear visibility into the future improvements via the upstream roadmap. This is what I was commenting before. Regarding maintainability, the smaller your delta with upstream, the simpler long-term maintenance will become, and also the easier adopting new versions will become as well. Also, by staying closer to upstream, you can keep your code base healthier, you can reduce your backporting pain, and make sure that upgrades are smooth and predictable, which should translate into lower maintenance costs. As for alignment with upstream, the closer you are with upstream, the easier it will be for you to ensure that WPE roadmap will consider your real world use cases. This is something that is not obvious. Like upstream, for you, it might be obvious why WPE doesn't have this functionality, but for upstream, sometimes we just don't know, right? So if you stay closer to upstream, you can communicate your use cases. It's easier that upstream can take them into account in a way or another. And your contributions, therefore, will help shaping these priorities and will result in features that will serve you, not just you, but also the broader ecosystem. And will help you earn a reputation in the community, which takes me to the last benefit, which is community support. And this is important because the upstream project is full of domain experts. This is a massive project, so it's impossible to find someone who is an expert on everything. But if you have a closer relationship with upstream, it's easier for you to get support when you find an issue. And support from specific people, specific experts in specific domains is very valuable in this kind of projects. So yeah, this will make your troubleshooting much faster, much pleasant. And on top of that, over time, your team will also gain expertise and knowledge. So you can also consider this as like helping your internal training and lowering your dependency on externals to continue doing work. So yeah, like I said, getting closer to upstream is very important. So a few ideas for best practices for successful integration we were thinking of when preparing this presentation. The first one, I cannot stress this high enough, open communication. This is an upstream project. We wouldn't be here if not because the WebKit project was an open source project. WPE wouldn't exist if not because of that fact. The WPE team upstream is a small team, so this is the fact that we've been always open is what has helped WPE get here. So you, as a product integrator, you can do the same. And we recommend that you are as transparent as possible, sharing your progress, your blockers, your updates, but also sharing your goals, at least the goals that you can share. Because if you do that, it will be easier for you to define those goals with the help of the community. Again, the community will be aware of what you need. Even if you have non-standard requirements, this is useful. And engaging with the community, you can engage in many other ways, like asking for code reviews. This is one thing. And the other is getting feedback when you have an idea for a future of how you want to implement this. So being open is very important. It will prevent, as benefits, it will prevent you that you diverge too much from upstream in a way that will complicate maintenance later on. It will also make it easier for you to resolve issues because you will be able to lean on the expertise of community experts, and it will build a better long-term relationship. Like I can tell you, for instance, that when we started contributing to WebKit, it was much harder for us to land patches in WebKit than it is now. And it's after 15 years contributing, we have earned a reputation, and it's much easier. And what I guess I'm trying to say is that you, as product integrators, you could do the same thing. Revising more frequently, well, this has two sides. The first one is we recommend that you try to keep your deltas as small as possible and then revise as often as possible so that when you try to integrate a new release, it's as less, drama-free as possible. And there's always going to be conflicts you have to resolve and problems you have to resolve, but it's not the same to resolve issues when you have a massive fork and you diverge a lot than when you are following upstream much more closer. On top of that, if you revise more often, you will also get faster access to features and fixes, including security fixes, so this is very important. And debugging and troubleshooting will become much easier. So I don't know if you ever had to bisect a long commit range, but definitely if the commit range is huge and the commits are huge, bisecting becomes much more problematic than if you have smaller patches and you revise more often. And very importantly, because we have observed companies not always do this, actually many times they do it the opposite way, we recommend that you do all your development on the main branch, on the tip of the tree, instead of doing it on a stable release. It's very tempting to take the stable release because it's stable and you want an stable product and then put your patches on top. But if you do that, once you have find an issue and you report that issue, upstream is fixing things always on the tip of the tree. So if you're working on the tip of the tree and you find an issue, that's very natural. You just provide the patch and you provide the fix maybe, and that's more natural. On top of that, you have an idea of what upstream is working on, so you can decide whether you're going in the right direction. But if you are working on stable branches, you are continuously running behind. It's basically like you are putting stones before you all the time. Stable branches are still useful, but just for product stabilization. We recommend that you create the stable branches when you want to stabilize, and you put your patches, your security, bug fixes on top of that. And if you can align your stable branches with the upstream stable branches, that's even better. So the benefits of doing this right is that you will minimize your maintenance effort, your new releases integration is going to be much nicer, and enable faster innovation. What this means is that you get more time to do what really matters, which is working on features and not just completely running behind all the time. And then also, of course, another recommendation is contributing back upstream as much as you can. Not just code, just even discussions or documentation or sharing your ideas in public forums, in public trackers is very important. Of course, if you have merge requests or patches, this is also important that you do it as soon as possible. Some people take a long time to provide patches for review because they think my patch is not good enough. Of course, try to make a patch that is already decent enough, but getting early reviews is very important, and early feedback, because you might be on the completely wrong track. And if you share your patches sooner, then you get that feedback sooner. And try to document your decisions as much as possible. If you follow these ideas, you will find yourself writing eventually higher quality patches, being able to identify issues much faster, and you will have a shared ownership of the code base as well. But when you contribute patches, it's also important to do it in an upstream-friendly way. What I mean by this is try to avoid massive patches, try to do small updates. They are much easier not just to implement and land, but also for reviewers to review, to test, to backport. If you have an issue in the future, it's going to be much easier to identify which exact commit caused that issue. So basically, this is important, but also, in general, having an upstream-first mindset. So if you're going to fix something, try to avoid hacks and workarounds as much as possible. I understand that sometimes there are tight deadlines, but even when you have that, try to keep this in mind that the idea is to always consider the long term, always try to do the right patch, even if it takes a bit more time. It will pay off in the future. And when you write a patch, also pay attention to the commit messages. Try to describe not just what the patch is doing, but also why it's doing it. What is this patch coming from? If you do this, again, the benefits are multiple, but in general, you will see that your review process is going to be more simpler. You will get a higher acceptance rate. Your troubleshooting will be easier and bug fixing and debugging in the future. And in general, you will build more trust with the community. And last but not least, automation. Test automation and continuous integration, this is something that you should set it up as soon as possible. Not just for detecting regressions, which is important, including performance regression. It's also useful to do checks that are downstream specific, like pre-integration testing of your patches on top of the upstream baseline. But also you can set up CI for checking changes happening upstream in a way that is important for you. Let's say that upstream is increasing the minimum version of this dependency. If you don't detect that, you might end up having trouble later on down the road. But if you have this CI to detect those kind of things that break your particular use case, you will be able to react much faster. The benefits of this is, like, importantly, it won't fully avoid, but it will prevent you from getting big breakages from things happening upstream. It will also make you more confident in the changes that you are doing, because you know that, you're making this change, but you cannot be on top of everything. But if you know that there is a CI behind you that is checking all kind of things, you will develop with more confidence. And the end result is you will have more stable product and a higher quality product. And now I'm about to get into the end. So I prepared three real world case studies. I'm not saying names, but these actually are inspired in customers and relationships that we have done in the past few years. So I went from worst to best. Probably the more realistic one is the one in the middle for many of you. So the worst case is when you have, like, let's say, a company that has millions of deployments of WPE, but has a massively big fork. By massively big fork, I mean that's something that has a lot of downstream patches on top of them. To make it even worse, they work on top of stable releases and put the changes on top. They rarely contribute patches upstream. Sometimes they do it, but even when they do it, they don't do it in the best possible way. So it takes a long time just to get accepted, and the end result is not the best. And the worst part is that they rebase not often enough. In a case that I have in my mind, they've been rebasing for, like every 1-2 years, and then when you get a new version, sometimes you even have to skip versions, and the conflicts that you have to face are massive, and it's a big problem. So yeah, they face a lot of challenges. Like, as you can imagine, integration is hell. When moving to new versions, it's very difficult to innovate, to keep up with security patches. It's almost impossible sometimes. It's very hard to get support from the community. If you have this massive fork and a lot of patches on top of it, and on top of that is based on a version from 2 years ago, the community wants to help, but it's very difficult if you go down that road. And on top of that, you are start diverging, so your priorities misalign very much with upstream. So all in all, you will end up spending too much effort. This company will end up spending too much effort doing bug fixing and firefighting instead of working on important feature development work. The second case is a company that, even though they have downstream needs, they decided to stay as close to upstream as possible. So they have downstream changes, but they only do it, they are very strict, they only do it for things that are either not yet upstream, but they want to upstream, or things that are way too specific. They work on the development branch, so this means that they can innovate on the development branch, they can test things, even prototype them locally, even if it's with downstream patches, with the idea of then upstreaming them right away. And they only use stable branches for product stabilization, as I explained before. They also make contributing back upstream a natural part of the process, so when they have a patch they want to develop, they first think, is this possible to upstream it directly, or do we need to do like 2 stages? But they always consider that. And they rebase very, very often. And this might sound like science fiction for some people, but I've seen this case rebasing as often as every 2-3 weeks, sometimes even every week. And because they do it this way, these rebases don't take much. Sometimes they can do it in just 1 day. And also, I didn't mention here, they also use continuous integration to validate those rebases, obviously. And so this is a success story in our mind because the delta is kept to a minimum. They don't have to duplicate efforts because it's either, if it's fixed downstream, it's just temporary most of the times, but they try to fix things directly upstream. Product stabilization, they align it also with upstream stabilization, so it works really well. And basically, this upstream first mentality helps them align their business goals with the upstream roadmap. So they still have to do, the moral of the story is that they still have to do some downstream work, but they limit it a lot to their specific needs. Yeah, and they have better alignment, and that allows them to have more time for future work. And the last case is our companies in general. We have seen several of these in the past, that they work exclusively upstream. This in the industry is not always possible, we understand that, but when, for certain kind of projects like implementing web specifications or adding a new API or, I don't know, supporting more use cases or platform, is a good thing. And actually it's great to implement very complex features, like when you have to implement something like for instance, Bloomberg contracted Igalia to implement the CSS grid specification. Doing this downstream, I cannot even figure how you will do it, but it took a long time, but it's a good example of upstream-only work, or the new SVG engine that we've been working on. So there are many benefits of doing this. First, you don't have any delta, so integration becomes much more simple. You don't have to, have this dance between contributing back upstream or keeping a patch downstream and then dropping it, because you just do it naturally. Upstream won't break your feature because your product doesn't depend on a combination of upstream plus some downstream work. And yeah, and this is kind of something that I like, that is that you are improving the technology for everyone. But even if you are improving the technology for everyone, you are getting still a benefit. And the benefit is that you have a say on how the work upstream is prioritized in a way that is important for you. So in other words, if you don't do this way, if these companies wouldn't do this in this way, maybe they will end up getting CSS grid down the line, but not maybe according to their timeline. So prioritization is also important. This is ideal. We understand it's not always possible, but it's ideal because, it basically makes you more efficient as possible. So, yeah, I'm going to wrap it up. So how to use WPE effectively? I don't want to repeat things, so let's organize it in a different way. Like, I see 3 pillars here. The first one is, in case it was not clear, engage with upstream as much as possible. Try to align your goals with the upstream releases, the upstream roadmap. Try to get into the mindset of contributing back upstream as much as possible, quality patches, and engage with the community and discuss and get feedback. And do that all in public forums as much as possible. Second, develop your products on top of the upstream development branch and use the stable branches only for stabilization. I cannot insist on this high enough. Of course, you can still, update the stable releases that you ship, but only for bug fixes, security fixes, stuff like that. But any new development, you should continue it in the tip of the tree, as upstream does. And sometimes there will be things in upstream, in the tip of the tree, that are not stable enough or are not interesting for you. Don't let this be an excuse to go back to using stable releases and putting your patches on top, because you can always disable these things or discard them while they are not good enough for you. Last but not least, maintain and evolve automated CI, specifically thinking of your product and your needs. This is important, will help you detect regressions. You should also have a policy to handle them when they happen. It's important also to check that upstream versions, the upstream project is not breaking your use cases. You can use CI for that as well. And we recommend also to automate performance testing as much as possible. So in a nutshell, you could summarize this as consider WPE as an open source platform for the long run. Embrace upstream collaboration as much as possible, instead of treating it as just another package that you just integrate and use, and you fix things when you're done. And I think that's it. So yeah, I don't know if there's any question or comment. Sorry, let me get you the microphone.
Hello. So thank you for the talk.
Thanks.
So right now, if I'm using another engine like Chromium, right, and the application is use the Vue application to build for my embedded device. So if I want to change to WPE, what is the kind of like general guideline and how much work we need to do?
So you mean that you're using Chromium, and what you will need to do if you wanted to switch to WPE, right?
Yeah.
Is that the question?
Yeah, to improve the performance if you have.
Yeah, so it depends a bit on your use case. So if you are using Chromium to have like a fully fledged browser with, you know, all the features from a web browser like this, address bar, the back and forward buttons, cookie management, all those kind of things, nothing like that is present in WPE. WPE gives you the web engine and the necessary hooks and backends so that you can plug and set up your application on top of that. If you are using Chromium just to render a website and letting the user interact with it, WPE could also be a perfect fit. What you will need to do, you will need to compile WPE, set it up to your needs, define what are the output and input devices that you want to use, maybe it's a screen and a keyboard, plug that, and then load the web application. It's basically this, it will be basically the same thing that you will do with Chromium, but with WPE. But yeah, the thing is that you won't have like a fully fledged browser down from the start, but you will have the web engine that if you can use also the defaults backends for input and output, you can use it right away. And actually, in the past, using WPE was harder because there was, you have to deal with backends manually, but now we've been working for the past 2 years on a new API that makes this so much simpler. As simple as basically you just build WPE, you run it, and if you don't do anything, it will also automatically select for you the backends that you can use. So it shouldn't be too hard.
So it does support like something like touchscreen, right?
Yeah. I mean, yeah. By default, the default backends support those kind of things, yeah. But it's also up to you. So if you want to have, like, say, a virtual keyboard, that's up to you. You can use, if you are in Wayland, you can use maybe the Western keyboard for that, but it's up to you. You can use the default ones or just provide the ones that you want. So if you generate touch events on a screen, for instance, those touch events are going to be passed down to WP.
Oh, okay. Thanks.
Any more questions or comments?
Yeah, thanks. Mine's very similar to his. I have an application that's an HMI industrial product. Right now it's running Chromium in kiosk mode, so we're not using any of the browser features or anything. And then the actual UI is all written in React. And I'm very familiar with working on V8-based systems and all the quirks and stuff that come with the V8 engine and React on that. Can I just literally rip out Chromium and drop this in, and as long as the touch inputs are recognized and everything, it should drop in perfectly?
Yeah, I mean, devil is in the details, but it should be possible. Yeah, you have what you're describing is a regular web-based application. You're using React as your framework, but there's nothing that prevents you from, instead of Chromium, loading your application with WPE, with the web engine, and you will get it rendered. And then for the events, for the input events, you should be able to handle them as well. But it also boils down a little bit to the specifics of the input device. I don't know if it's a regular touch screen or if it's something else. But yeah, should be. This is what it's designed for. Thank you. Any more questions or comments? Yes?
So in terms of performance, right? So
sorry, say again?
In terms of performance, right? If we have the Chromium engine in there, so how much kind of generally like the power processing between like the WPE versus the Chromium?
Oh, you mean the performance?
I mean that the CPU uses.
Okay, so this is a really interesting question as well. So as usual, it depends, but in general, WPE these days is quite performant. I cannot tell you because it depends a little bit on several aspects. It also depends on the specific application. But in general, WPE is very performant these days. It used to be the case in the past where performance was not that on par, but these days, especially in the past 2 years, I don't know if you are familiar with Skia, which is the 2D rendering library that Chromium uses for 2D rasterization, is extremely performant and can also use the GPU hardware acceleration when enabled. So in the past year, we actually migrated WPE to Skia as well. So now the difference is they are very much on par, but there are some cases where WPE now is actually much more performant.
So let's put the question that way. So currently we run with the kind of like the IMX8 microcontroller, IMX8 and XP, and like the Chromium, it kind of like run about 50% of the CPU for our case, right? So if we drop in the WPE, so like roughly what's the estimation? Is that any saving in terms of power?
I mean, I cannot tell because I don't know the specific of your device. What I can tell you is that in similar situations, and we do work with IMX boards, we work with IMX6, with IMX8, different variants of those boards with the plus, the non-plus. And what we have observed is that WPE is performing really well. In some cases, we need some adaptations. I won't lie, for instance, one of the advantages of Skia is that before Skia we used Cairo. Cairo didn't allow any hardware acceleration, GPU-based acceleration. Skia allows that. We did the migration last year, and we got to the point where if you are using the CPU backend of Skia, you get comparable performance to Cairo and Chromium. On embedded, in particular on IMX, on the Raspberry Pi, we cannot yet enable the GPU backend, not yet, because the performance is not good. It's really good on desktop, like several times better than it was before. But on embedded, you have to use the CPU backend. What this means is that, what I'm trying to explain is that performance is similar to Chromium in those cases, only that we are now actively working on being able to enable hardware acceleration also on embedded devices. So let's say that we are at the beginning of the potential that we are expecting to see in the next months. So once we enable that, the performance should be much better. But again, it depends a bit on your case. What I can tell you is that, for instance, the resources footprint, the memory footprint or binary size for WPE is much, much smaller. And it might not be an issue for you, but in many cases in embedded, binary size alone is already a big issue.
Okay, thank you.
Thank you. More comments or questions? Okay, thank you.